If we're asked to simplify 1 over x minus 1 over 3 over 4, notice what we want to do. We want to get a common denominator of the numerator. I'm going to leave my denominator of the whole fraction is 4, and to get a common denominator here, I simply have to multiply 3 times x. Now, what am I doing? I'm going x becomes 3x. Well, clearly that's times 3. But I can't introduce a 3 to the denominator of the numerator without also introducing a 3 to the numerator. 3 becomes 3x, so I'm going to multiply by x over x. So 3 times x is 3x, and negative 1 times x is negative x. By the way, this is a complex fraction. So what is the denominator of the denominator? 1. Now I'm going to keep, change, and flip. I'm going to keep my numerator. So this is equal to 3 minus x over 3x. Change division to multiplication. And then I'm going to flip my denominator. You see why it was useful to me, right, to write this as 4 over 1. Because now this becomes 1 over 4. Remember, the rule is numerator times numerator and denominator times denominator. So I'm going to say this is 3 minus x times 1 over 4 times 3x is 12x. And I have simplified this. If we're asked to simplify the square root of 3 minus x and the square root of 3 plus x, recognize we have conjugates of the form a minus b, a plus b. And what's nice is when we FOIL conjugates, the OI disappears. So let's see. First times first will give us the square root of 3 times the square root of 3 is the square root of 9. Outer is plus x square roots of 3. Inner is minus x square roots of 3. And last is minus x squared. Now, I could have written this as the square root of 3x, but a lot of students say, well, does the square root go over the x or not? To show that it doesn't go over that, I like to put the x, which is not in the radical, in front. Now, if these have been good little x squared to 3, they go off to number heaven, and we get 3 minus x squared. Notice this is a binomial, and we would call this a difference of perfect squares, although we're going to have to use a radical there.